Hello. So this is the first video to help you revise the differentiation content from chapter 5 or topic 5. There's a few videos in this sequence all around the basic rules of differentiation. So we're going to start with chain rule, and then there are future videos on the product and quotient rules, tangents and normal stationary points, and so on. But chain rule is one of the real key things you need to be able to use to do anything in differentiation. So looking at chain rule, we're assuming that you can already differentiate single functions. So we're assuming that you can differentiate things along the lines of something like this. And that you know when you differentiate something, notation that we use is dy by dx, and that you can use the basic power rule. That is in your formula booklet. So it says that if y is x to the n, dy by dx is nx to the n minus 1. And so here x cubed turns into 3x squared, and 3x half would turn into 3 over 2 x to the minus half. So it's assuming you already know these basic rules of how to differentiate single functions. What the chain rule is for is how to differentiate something like I've written on the right here, this example 1. So where we haven't just got one function at a time, we've got what we could call composite functions. And so we can't just use that basic rule of differentiating every term that we see. So what we do, and the formula is in your formula booklet, and it writes it like this. It says that if y is some function g of u, then dy by dx is dy by du times du by dx. So in this instance, we can say that u is x cubed plus 2, and that y is u to the half. So that's our composite function. We're not multiplying functions. What we're doing is x goes in, it gets cubed and gets 2 added to it, and then that result is then put to the power half. We often call this one here the inner function. In a minute, you'll see me refer to that a lot more. So we would often call this the inner function and this the outer function. So the rule says that dy by dx is dy by du times du by dx. So that means if we've got u, we need to differentiate u in order to find du by dx. So x cubed, the 3 comes to the front, the cube turns into a squared, and then the 2 disappears. And the y term, dy by du, would be half u to the minus half. And be careful taking the 1 away when you're dealing with fractions. So then our dy by dx is these two things multiplied together. So 3x squared times half u to the minus half, which we would probably prefer to write as 3 over 2 at the front, x squared u to the minus half, and to finish it off, we should replace the u back with terms in x. You may have preferred here to write your final answer like this, because power minus half, the half means a square root, the minus means it should be on the bottom of a fraction, but that's optional. There's nothing wrong with my first answer. So that's how to use the chain rule from the formula booklet. But we use this rule a lot. It comes up inside lots of other rules. So product and quotient rule often have chain rule within them. And also, it's something we do so often, it's helpful to have a quicker way. We can call that quicker method the inspection method. And ultimately, it's up to you which you prefer. I recommend the inspection method just because I find people make fewer mistakes when things get a bit more complicated, as well as for time issues. But if you really like using the chain rule from the formula booklet, you can keep doing that. That's not a problem. So the inspection method, there's not really a formula for it, but we can describe it in words. The way we describe it is differentiate the outer function first and then multiply by the derivative of your inner function. So I've got another example here. Usually the inner function, you could describe it as the one in the bracket, and then the outer function most often would be some power outside. As we get further through the syllabus, it might be an ln or a sine or a cos. But at the moment, we're just dealing with questions like this. So the first step I said was differentiate the outer function. So we look at our question, we look at the outer function, it's -3. So if I want to differentiate something with a power -3, I would bring the -3 to the front, and then I would take 1 away from it in the power. So I multiplied the -3 to the front, I subtracted 1, and your inner function, you just write it in its bracket where it was. So it's almost like in my head, I'm imagining this 5x plus 2 is just an x. So I'm kind of pretending like it's just an x for a minute. But I write it down as the 5x plus 2. Once I've done that, and the key here is you write that down, you don't do it in your head, you write it down. Once you've done it, then you look at your inner function. So now I pay attention to 5x plus 2, and I want its derivative. Derivative of 5x plus 2 is 5, and we're going to multiply our answer by that 5. Quite often, once you've done this, you'll find that certain things might simplify or cancel out, for example. So here I've got -3 and then multiply by 5 at the end. So I'm actually going to write -15 because that's a little bit neater. And there's our answer. So the trick for this inspection method is not to try and do the whole thing in your head and immediately write my final answer, but to do these 2 steps, to put them down and then simplify. And we can see it took less writing than the first example. It was a little bit quicker, and kind of that's quite a useful thing to do. So what I would like you to do now, I've got 3 questions for you to try. So what I want you to do is to pause this video to try those questions. And then when you've given it a go, if you press play again, then you'll see my solutions to them and you can check that you're correct. Or if there's one you were stuck on, then you can see how to do it. So if you're ready to try your questions, press pause. I'm going to keep talking and do the solutions. I'm going to do all of them by the inspection method. So on this first one, there's my outer function, the 4. So 4 comes to the front, and the power turns to a cubed. So I've done the outer function. The next part is my inner function, 6x minus 5x squared, and the derivative of that is 6 minus 10x. And because it's got 2 components, I need to put them in a bracket. And don't forget that you should always write dy by dx equals to make it clear that this is the derivative. I could write this in a different order, but it wouldn't improve my answer, so I'm just going to leave it like that. There's no obvious simplification to do. If you've written it in a different order, you're just as correct, so don't worry about that. Right, the next question. Now, before you started this question, hopefully you recognise that you need to write the square root as power half. Now it looks a little bit clearer where we've got our outer function and our inner function. So same technique again. Outer function is power half. So half comes to the front, we take one away from it, we get minus half. I'll write that 2x cubed minus 7 in here. Then when we multiply by the derivative of the inner function, 2x cubed will go to 6x squared, and the minus 7 will have disappeared. And I can simplify because I've got a half at the front and a 6x squared at the end, so I would prefer to write that as 3x squared. And you may have chosen to write your answer like this. That's not necessary, but if you've done that, you're still correct. And notice this time the question said f of x, so I wrote f dashed of x equals. And final question. So this one, again, it's not written in the nicest way to start with. So I would probably choose to write x half instead of root x, and then minus 2 for the power. So we've got 1 over something squared, so on the top I can write that as a power minus 2. And again, we've got inner function here is my x half minus 3, outer function is the minus 2. So dy by dx, minus 2 comes to the front, turns into minus 3. That's my outer function. Then my inner function, the derivative of x half is half x minus half. And then I've got simplifying to do. I've got a minus 2 at the front and a half here. So they're going to cancel, but they will leave a minus. So I would probably write my final answer like this. So just put minus x, the minus half at the front. And again, if I really wanted to, I could write this as minus 1 over root x minus 3 cubed. But that's not necessary, that's optional. Okay, so that's the end of the first video in this topic 5, differentiation. So if you want to keep watching, we'll be looking at product and quotient rules next. But you may want to try some practice exam questions or homework questions on the chain rule first if you're still feeling a little bit unsure of it. And that's all from me. So I'm going to stop recording now and say goodbye to everyone.